All right, today in geometry, we're going to spend more time on rationalizing the denominator. Remember that rationalizing the denominator is the process of changing the denominator from a radical to a rational number. So in order to rationalize the denominator, you simply multiply the numerator and denominator by the radical in the denominator. So we did this yesterday. So today we're just going to do more practice on this. So number one, 18 divided by the square root of 2. Remember that 18 is not underneath the radical, 2 is, so I cannot combine them. So I need to get rid of the radical in the bottom, so I simply multiply by that radical. But whatever I do to the bottom, I have to do to the top as well. So on top, I have 18 square roots of 2 divided by, remember the square root of 2 times the square root of 2 is just like the square root of 2 squared. Squaring a square root undoes it, so I just have 2. Now I have this 18 and 2 that are not underneath the radical, and I can combine them. 18 divided by 2 is simply 9 square roots of 2. Here's our answer. Number 2, 16 divided by the square root of 3. The 16 is not underneath the radical, 3 is. So, and the 3 is in the denominator, multiply top and bottom by that 3. So on top, I have 16 square roots of 3 divided by the square root of 3 times square root of 3 is just 3. 16 and 3 are not underneath the radical now, but they don't have anything in common, so that's our answer. So a radical is considered to be in simplified form if the following 3 conditions are met. Number 1, the radicand contains no factor that is a perfect square when dealing with square roots, a perfect cube when dealing with cube roots, etc., etc., etc. Remember that the radicand is the number or variable anything else, so the number, variable, etc., under the radical. The radicand has no fractions, so there's no fraction underneath the radical, and the denominator contains no radical. Once those 3 conditions have been met, then our radical is simplified. So we're simply going to simplify. So number 1, the square root of 5 divided by 18. Again, we're going to be looking at all of those rules that we talked about yesterday and which one applies. So I have 5 and 18. They don't have anything in common. I can't simplify that, so I can go ahead and break this apart and make this the square root of 5 over the square root of 18. But I notice that the square root of 18 in the denominator, I can do factor tree on. So that's 9 and 2. 9 is 3 and 3. So I have a 3 that comes out, 2 that gets left behind. So now I have the square root of 5 over 3 square roots of 2. Now the radical is the square root of 2, so multiply top and bottom by the square root of 2. On top, I get square root of 5 times square root of 2, both underneath the radical, square root of 10. Over on the bottom, I already had this 3. Square root of 2 times square root of 2 is 2, so I end up with 3 times 2, which is 6. 10's underneath the radical, 6 is not, so I cannot simplify them. So the square root of 10 divided by 6. All right, number 2, I had the square root of 1/2 times the square root of 5, 6. I simply multiply my numbers underneath the radicals together. So, and remember to multiply fractions. I multiply the tops together. So 1 times 5 is 5. 2 times 6 is 12. So now I have 5/12. I cannot reduce that by anything, so I'm going to go ahead and separate it. Top is square root of 5, the bottom is square root of 12. Again, I can do factor tree on 12. That came from 4 and 3, 4, 2, and 2. So on the top, I still have the square root of 5. The bottom, I have 2 square roots of 3. I cannot have that radical in the denominator, so I multiply top and bottom by that radical, the square root of 3. So on top, square root of 5 times square root of 3 is the square root of 15. Over on the bottom, 2 times 3. So I get the square root of 15 over 6. Number 3, I have 5 divided by the square root of 24. I notice right off the bat in the denominator, I can do factor tree on 24. So that came from 12 and 2. 12 came from 4 and 3, 4, 2, and 2. So I have a pair of 2's, a 3 and a 2 that get left behind. So on top, I have 5. On the bottom, I have 2 square roots of 6. Multiply top and bottom by the square root of 6. So on top, we have 5 square roots of 6 over, on the bottom, 2 times 6 is 12. 5 and 12, nothing in common, so there's our answer. Number 4, 3 divided by 2 square roots of 8. Again, I notice I can do factor tree on 8. 2 and 4, 2 and 2. So I have a pair of 2's. So on top, I still just have my 3. On the bottom, I already had that 2 out front. So I multiply that with the 2 that comes out. So I get 4 square roots of 2 left behind. I can't have a radical in the denominator, so I multiply top and bottom by that radical. So on top, I just get 3 square roots of 2 over on the bottom. 4 times 2, 8. 3 and 8 can simplify, so there's our answer. All right, let's go to the back. Number 5, the square root of 70 divided by 4 square roots of 10. I notice I could do factor tree, right? Or sorry, not factor tree, on 10, because that's just 5 and 2, so I can break down the top 10 and 7. And I can break down. But both underneath the radical, 70 and 10, I can go ahead and combine those, simplify because they're both underneath the radical. So 70 divided by 10 is 7. So this really simplifies to the square root of 7 over just 4. I cannot do factor tree with 7. I don't have a radical in the denominator anymore, so we're done. Number 6, I have 4 square roots of 5 over 3 square roots of 20. 4 and 3 don't have anything in common. 5 and the 20 are both underneath the radical. I notice that I can go ahead, that 5 goes in that 24 times. So on top, I just have 4 over on the bottom, 3 square roots of 4. The square root of 4, that's a perfect square, right? So on top, I have 4 over 3 times 2. So I have 4 over 6. But that will simplify. They both have a 2 in common, so that reduces down to 2/3. So all of my radicals went away there. Number 7, I have 17 square roots of 6 over 4 square roots of 3. Again, the 6 and the 3 are both underneath the radical. I can divide 6 and 3 and get a nice whole number. So that becomes 17. 6 divided by 3 is 2, so I have the square root of 2 on top. The 2 goes on the top because that's where the bigger number 6 was, all over 4. 17 and 4 don't have anything in common to simplify. There's our answer. So remember, be looking for these 4 rules that we talked about and which one is the easiest, okay? And it's going to give you the less work. Number 8, 20 square roots of 3 divided by the square root of 3. Okay, what's the square root of 3 divided by the square root of 3? 3 divided by 3 is just 1, right? Or they cancel each other out. And I'm just left with 20. The last one that we're going to look at today. So number 9, 8 square roots of 20 divided by the square root of 5. 20 and 5, again, they're both underneath the radical, and I can divide that and get a nice whole number. So I still have that 8 out front. Underneath the radical, 20 divided by 5 is 4. But I see that 4 is a perfect square, so this is really 8 times the square root of 4 is 2. 8 times 2, 16. So this was just another quick practice of rationalizing the denominator. Your homework today is called Rationalizing the Denominator Worksheet. Again, it can be found in Canvas in today's announcement or underneath the assignment tab as Rationalizing the Denominator Worksheet. We will be taking a quiz this Friday over everything that we've reviewed with radicals, adding, subtracting, multiplying, dividing, and rationalizing the denominators.